We want to see the first elements, which is on the row 1 and colors 1 in this new matrix. How would you get that numbers? So it's actually from, you take the first row of the columns A here and do the inner product with the first columns in B. So that's how you get the first elements in this new matrix. Okay, and you do the same. For example, like this, the M row and first columns. Okay, so that means we are going to take the M. There's no C here. We are going to take the M rows from the matrix A and the first columns in the matrix B and do the dot product, inner product, and then get the numbers here. So you can do it continuously to construct the whole new matrix here. Okay. Right. So we can do A multiply B, and can we do B multiplied by A? I saw someone shaking your head. Yeah. So the correct answer is not necessary. Like you can only do that if and only if like M and P is the same numbers, of course. Like yeah. But generally that is not true. So be careful when you see that I can do A times B. Doesn't mean that you can always get B times A. Just keep that in mind. And that's why I say that sometimes you just put down the dimension of your matrix, you'll figure it out like you got something wrong, because there doesn't make any sense if you cannot do the multiplications here. Okay. Right. Right. Let me go through this page very quick. Then is the transpose. So what is transpose? Yeah. So transpose is like we kind of flip. Okay. Again, imagine this is a paper, and we just flip it. Okay, so that would be a good practice to do it here. Okay, so just for the illustrations, this is the transpose of the matrix A, and I keep the original way we kind of denote the elements in that matrix. So it's like we totally flip it. So the first columns will become the first row of the transposed matrix. So you can see that originally this is the first column, now it becomes the first row. Okay, and of course like the second column will become the second row. So here you can see the second row is look like this one, and it goes up, and you continue this process and get the new transpose matrix. Okay. And sometimes we use T, sometimes we will use plum to represent the transpose operation. But yeah, that's it. Okay. And then trace. Trace only makes sense in the n by n matrix because it's going to add up all the diagonal terms. Okay, says that now we have the n by n matrix A. Say again. Right. Put it this way. 2, 1, and 1. 1, 2, 1, A, 2, 2, A, 3, 3. Okay, so what trace operation does is to add up the elements on the diagonal, the diagonal positions. Okay, and yeah, so I never think of why the trace does not go to the other diagonal way, but I don't know the answer, but. That's how it defined. It goes from like 1, 1 to n, okay, instead of like n1 to 1n, that kind of stuff. But that's just a random thought here, right? So it's about the time. We will have like 15 minutes break and come back on 30th. Thank you.